All right, Unit 3, Day 3, partial fractions. Partial fractions. The official word for what we're going to be doing is decomposing. That sounds pleasant, doesn't it? A better word for it, though far less technical, but maybe more explanatory, is we're going to be unadding fractions. So on Monday, Tuesday, Unit 3, Day 1 was adding fractions. Now we're going to unadd fractions. And then maybe that seems weird to say. But let's start with, basically we're going to start with the answer and figure out where it came from. So it's kind of a game of Jeopardy. If you haven't watched the warm-up for today or the worksheet problem we did, you should probably go back and watch those, because those skills are going to be helpful in unadding, right? If you can't add, it's really difficult to unadd. So assuming you can add fractions, let's talk about unadding fractions. So again, what we would start with is just this answer, 5x minus 8 over x times x minus 4. You're like, what am I supposed to do with that? That looks like perfectly good to me. Well, I want us to unadd. I want us to decompose that into partial fractions, into two fractions. So we haven't done a ton of these, but you've probably done enough to know that if this was your answer, the two denominators were probably x and x minus 4. Good with that? Does that make sense? Like that's what the two denominators are. What we don't know is what those numerators were. So let's just call them A and B and see what we can figure out. So again, this is why it's unadding. Up until now, we started with the right-hand side. We told you what A and B were. You got a common denominator. You added the tops, and you ended with this. Today, work it backwards. All right, well, we generally don't like denominators, so let's just get rid of all the denominators in our very first step, and then we won't even have denominators to worry about. So let's multiply through by everything that's in the denominator. And for the first one, I'll show a step that once we do some of these, you probably won't show. I am going to write x and x minus 4 on each one of the fractions. You may think this is overkill now. Hopefully, after a few examples, you'll definitely think it's overkill. But for people who struggle with fractions and multiplying, it's an important step to see. So we'll show it this time. Alright, so the reason we multiplied by the common denominator was that all our denominators should go away now. So on the left-hand side, the x's cancel, the x minus 4's cancel, and we're left with just 5x minus 8. On the a term, the x's cancel, and so that just leaves us with a and x minus 4. And on the b term, the x minus 4's cancel, and that leaves us with b times x. Again, once you worked a couple of these, it'll be easy, relatively easy for you to go from step 1 to step 3 without showing that step. Because you can just see, well, everything cancels, then the x cancels, then the x minus 4 cancels. All right, the next step is maybe the tricky part. We want to pick a, quote, good value of x. And a good value is a value that makes some stuff go away. Like our goal is to find a and b. And this statement is true for all values of x. So I get to pick anything I want. But there's some good values of x that make things go away, and there's some bad values of x that don't really help. So any guesses on what would be a good value of x to pick? I'm really looking right over here. What might be a good value of x? If you could pick anything in the world that would simplify this problem, what value of x would you pick? What's that? 4. Good pick. Let's pick 4, because that'll make this go away. So if we plug in 4 for x, so we got to plug in 4 everywhere. But we know good times are ahead because we wiped out the a term. 4 minus 4 is 0 times a is gone. So that was a great pick for x. So on the left, 20 minus 8 is 12. On the right is 4b, so b equals 3. So they're part of our answer. We're looking for a and b. We just found b. Let's pick another good value of x. Looking back at this original, or this step. So x equals 4 was a great pick. What would be another good pick? 0. If we pick 0, then this term will go away. So let's pick 0. So 5 times 0 minus 8 equals a times 0 minus 4 plus b times 0, which goes away. That's why we picked it, to make that happen. So negative 8 equals negative 4a. A equals 2. Generally speaking, you're not guaranteed to get integers, but if we write the problems well, you will get integers. So if you get crazy fractions in here, you probably did something wrong. All right, we're not done yet until we write the partial fractions. So we've done all the work. We just need to go back to our original statement up here and write 2 over x plus 3 over x minus 4. So kind of a crazy problem to start with the answer. Trying to zoom out to get all of it in there. Can't quite do it. Start with the answer. Do a whole lot of work to come up with the question. Let's do another one of those. We're going to do one more. I'm going to skip an example. Actually, I'm not going to skip it. I'm going to shorten it. So this is example 2, but we won't do all of it. X plus 3 over x squared minus 8x plus 15. It's really similar to the last one, so we won't do all of it. What do you think we should do first on this example? There's kind of an extra step at the beginning. Factor the denominator. So x minus 5 and x minus 3. And now we'd be ready to go set up our problem. So our denominators would be x minus 5 and x minus 3. And we'd be looking for a and b. Next step, we'd multiply through everybody by x minus 5, x minus 3. Since we're experts now, I'm going to skip that step from earlier that I said I would skip, because on the left, everything is going to cancel, and I'm going to be just left with x plus 3. For this a term, the x minus 5s would cancel, and I'd be left with x minus 3. And for the b term, the x minus 3s would cancel, and I'd be left with x minus 5. All right, here's where we'll bail on this problem. Tell me 2 good values of x I should use to find a and b. 3 and 5. Because 3 will wipe out this guy, 5 will wipe out that guy, and then I can figure out what a and b are. All right, let's do one more example, because this one's a little bit harder. There's something else going on in this last example. Negative x squared plus 3 over x plus 1 and x plus 2 squared. So I think pretty clearly I need an x plus 1 as a denominator. What else do I need as a denominator? What do you think? This one's a little bit different. What would the other denominator have to be in order for this to be the common denominator? So I do need an x plus 2. But this is a little bit weird. I need an x plus 2, not again, because that'd be the same thing, right? There's no point in having the same denominator written twice. But if I added all these, I wouldn't get a squared out of that. That common denominator wouldn't have a squared in it. So one of these has to be squared. So if you've got one with a power on it, you got to include the same factor without the power, and then the same factor with the power. So that's what makes that type a little bit strange. Now I want to multiply by something that will wipe everybody out. The common denominator is always the original denominator. So I'm going to multiply everybody by x plus 1 and x plus 2 squared. The left one's easy, right? Because that's what I multiplied by. Everything goes away. I'm left with just negative x squared plus 3. The rest of these get a little bit tricky. So when I multiply all of that to the a term, what cancels out? The x plus 1 cancels out, so that leaves a times x plus 2 squared. When I multiply it all to the b term, what cancels out? One of the x plus 2s. One of the x plus 2s cancels out. Not both of them, but one of them goes away, so that leaves me with x plus 1 and one of the x plus 2s. And then on the c term, back to easy, I think, x plus 2 squareds, both of them cancel out, and so that leaves c times x plus 1. All right, picking good values of x. What's a good value of x to pick? What's that? Negative 1's a great pick, because that will wipe out, that'll actually wipe out 2 things. So let's plug in negative 1. Careful with the negative squared stuff. Again, so everywhere there's an x, I'm putting in negative 1. And wow, what a great pick for x that was. Because it turns that to 0 and that to 0. So that's gone and that's gone. Kind of important to pick the right values of x. So -1 plus 3 is 2. A times 2 minus 1 is 1. 1 squared is 1. That was easy. So A is 2. So there's part of our answer. We got to find A, B, and C. We found A. Some people kind of check them off as they go and make sure they've got everything, if that helps. Kind of help keep track of the problem. What's another good value of x to pick? Again, looking at this. What else could we pick? Pick on some people here. Daniel, what's another good value of x we could pick? Good, -2, because that'll wipe out this and this. So let's pick -2. Again, with the negative x squared thing, got to be real careful. Negative square of -2 plus 3 equals A times -2 plus 2 squared. Just plugging in -2 everywhere for x. And if we picked it right, things should happen that work out well for us. Let's see, that's -4 plus 3 would be -1. That A term is 0, so that's gone. This term is 0, so B times, doesn't matter what B is or what this is, when we multiply by 0, that all goes away. And we're left with -1 times C. So C equals 1. So great pick for x, that helped us out a lot. We now know A and C. We're getting close. Here's the trouble with this one. There aren't any good values of x left. Right? We made this guy go away. We made this guy go away. But -2 and -1 were the only values of x that zeroed stuff out. So this always happens when you get a squared term. You're going to have an extra value of x that doesn't work as well. So I'm going to pick anything else in the world that I like. It's not going to make anybody be 0, but I got to pick something. So I'm going to pick 0. You could pick 10 or 12 or pi or anything crazy you want, but 0 is the best way to go. So this one's not nearly as fun because nothing gets zeroed out. I mean, 0 goes in for x, but that's not nearly as beneficial as -1 and -2 was. Right? So everywhere there was an x, I put a 0. So 0 makes the math easy, I guess, but it doesn't wipe anybody out, so that's kind of frustrating. 2 squared is 4, so 4a plus 1 times 2 is 2, 2b plus c. So that's not nearly as satisfying as those other two values of x were, because they wiped things out. So what can I do? Do you see what I can do to... Like, I need b. That's what I'm looking for. What's going to help me figure out what b is? Do I know a and c? Yeah. So 2 goes in for a. 1 goes in for c. 3 equals 4 times 2. B we don't know, it's what we're looking for. Plus 1. Okay, now this is okay. I've got an algebra 1 problem. 3 equals 8 plus 1 is 9. So move the 9 over. Negative 6 equals 2b. So b equals negative 3. So I've got all my pieces now. I'm not done till I write my final answer. Just make sure you put the right A, you put stuff in the right spot. Like we know A is 2, so over the x plus 1 it needs to go 2. Over the x plus 2 is b, so that's negative 3. And over x plus 2 squared is c, which was 1. What a weird thing to learn how to do, how to unadd fractions. All right, the assignment is the worksheet on partial fractions. So you can print it. There's some factoring to do, and there's a few that are like this last example. So try those. I'll post some answers at some point, and we'll work a few tomorrow in class together.